Our next unit is probability. We're going to start on page 7 in our new books. Probability is defined as the measure of how likely an event is to happen. We hear about this all the time. Think of the rain. How likely is it it's going to rain today? What are the chances it's going to rain today? When you enter a raffle, what are the chances I'm going to win a prize? Those are the various things that we hear people say or we say ourselves in our day-to-day lives. One part of probability is something called likelihood, meaning how likely is it that something's going to happen? We could say there's a 100% chance of something happening. That means it is certain to happen, meaning there is a guaranteed chance that it's going to happen. For example, what is the probability you're going to have a test in this unit? 100%. That means the likelihood is 100% chance that you're going to have a test on a probability. You can also have something that's 0% chance probability. Something like, what is the probability that Ms. Bowling will start singing opera in class? 0% is the answer, meaning the likelihood of Ms. Bowling singing opera in class is impossible because it's not going to happen. Now, most things in life are not impossible or certain. They're somewhere in the middle. So we use the phrases or the words unlikely, equally likely, and likely to help us in determining what the likelihood, what the chances of it happening are. When solving problems involving likelihood and probability, there's this assumption out there that there's this prior knowledge you already have. And what's become evident in the past is that us as teachers, we assume that students already have this knowledge, and we've learned that a lot of students don't. So in order to help you remember these situations, we're going to go ahead, flip to your back cover in your book. It's blank. And I want you to just make note of these two situations because this is knowledge that, again, we assume that students already know and already have, but we have found that a lot of students don't. So the first thing we want to address is number cubes, which are known as die. You can say dice if you have more than one. And on a number cube, you have the numbers 1, 2, 3, 4, 5, and 6. So all number cubes, 1 through 6. We're not dealing with any funky role-playing games where they have cubes that have numbers higher than 6. So everything is just 1 through 6. The next thing we're going to deal with is a deck of cards. In a deck of cards, there are 52 cards. We are not talking about jokers and wild cards and all of that stuff. Take those out of the thought process. We don't deal with those. In the deck of cards, you have 4 suits. The red ones and the black ones. The red suits are going to be diamonds and hearts. The black ones are going to be clubs and spades. Now, in each of the 4 suits, they have the same numbered cards. They each have 13 cards in each suit. So there are ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, and king. And those cards are in each suit. So all 13 of those cards, ace, 2, 3, 4, 5, 6, and so on, are all in diamonds, and they're also in hearts, and they're also in clubs, and they're also in spades. There's an ace of diamonds, an ace of hearts, an ace of clubs, an ace of spades, a 2 of diamonds, a 2 of hearts, a 2 of clubs, a 2 of spades, a 3 of diamonds, a 3 of hearts, a 3 of clubs, a 3 of spades, and so on and so on and so on. Now let's use this information to answer some situations regarding likelihood. Let's now flip back to page 8 in your book. So in looking at page 8, you'll notice in the top right-hand corner, there's that same number line of likelihood that we can use to reference to answer these questions. And the directions are telling us to write a ratio to represent each probability if it's possible. However, each of these situations, it is not a guaranteed possibility. But one thing we can do is we can determine the likelihood. So in all the situations, we're going to determine how likely is it that that's going to happen. But in only some of them are we going to be able to actually write the ratio in fraction form for the probability. So let's take a look at the first one. If you roll a die, you will get a number less than 7. Well, we know that there are 6 numbers out of 6 that are less than 7 because all the numbers on a number cube or a die are less than 7. This means that we are certain to get a number less than 7 if we roll a number cube or roll a die. The second one says if you roll a die, you'll get an odd number. Well, we know our odd numbers are 1, 3, and 5. That means there are 3 out of 6 odd numbers. So we have an equally likely chance of getting an odd number if we roll a die. Letter C. Jody has dance rehearsals on Tuesday afternoons. How likely is it that Jody is at the mall on a Tuesday afternoon? Do not play the what if game in probability. What ifs will only lead to frustration because it will not lead you to the right answer. So no what if situations. At no point should you ever say, but what if this happens? So if Jody has rehearsals on Tuesday afternoons, it is unlikely that she is at the mall. We are not able to write a ratio because we don't have any numeric information to help us with this. However, we can't say that it's impossible she's at the mall, but she's probably going to be at dance rehearsal because she's responsible, so it's unlikely that she's going to go. So now in looking at letter D, a bag contains 12 pennies and 12 dimes. How likely is it you will draw a dime from the bag? Well, there are 12 dimes and there are 24 coins. That means there is an equally likely chance that we would pull a dime from the bag. Letter E. You must be 15 years old to obtain a learner's permit. Emily is 13 years old. How likely is it that Emily has her learner's permit? She isn't 15 yet, so it is impossible that she has her learner's permit. Do not play the what if game. We are unable to write a ratio for this one because we don't have any numeric values. Letter F. The club volleyball team is made up of 7 boys and 4 girls. How likely is it that the first player chosen at random will be a girl? Well, we know there's 4 girls out of 7 plus 4 is 11. We got the 11 by adding the 7 and the 4. So that means 4 over 11. Well, that's less than half because half of 11 is 5.5. So since that's less than a half, we would say it's unlikely that we would end up picking a girl first. Letter G. Cards are numbered 1 through 8 in the box. How likely is it you will pull out a number greater than 2? Well, the numbers greater than 2 are 3, 4, 5, 6, 7, and 8. That means there are 6 cards out of 8 that are greater than 2. It didn't say greater than or equal to 2. It just said greater than 2. So that indicates that it is likely the number will be over 2 because the fraction we have is over a half. And then for letter H, how likely is it the card you would pull out in problem G will be a number less than 4? Well, when we look at it, there are only 3 numbers less than 4, 1, 2, and 3, and there's a total of 8 cards in the bag. So 3 over 8 is less than half. That means that it is unlikely we would choose a card to be less than 4. Okay, so now let's get into what specifically is probability now that we've learned about likelihood. Probability is always going to be between 0 and 1. The reason is you're never going to have more than an impossible chance of something happen, nor are you going to have something that's more than guaranteed to happen. So we're between 0 and 1, meaning between 0 and 100%. So we will never have a negative percent or a negative probability, nor will we have something that's more than 100% or greater than 1 probability chance of it happening. So probability is a number 0 to 1 that measures the likelihood or the chance that an event will occur. And the outcome is the possible result of an experiment. So if we're going to roll a number cube, I have between 0 and 1 chance of it happening, and my possible outcomes would be rolling a 1, a 2, a 3, a 4, a 5, or a 6. Now, to actually roll the number cube would be your event. And an event is an outcome or a collection of outcomes. So we want to know what happened when we rolled the cube. What did we end up with? And sample space is the set of all possible outcomes, meaning what could happen. So probability of an event is going to be written as a ratio. So we are going to compare the number of outcomes meaning the number of times that it happened, compared to the total number of possible outcomes. So we're still thinking in terms of part over whole when we're writing our ratio. Probabilities are expressed as a number between 0 and 1, never negative, never greater than 1. The closer the probability is to 1, the more likely the event is to happen because it is getting closer and closer to that 100%. Now, probabilities, all your outcomes, when you add up the chance of them all happening, they should always equal 100% or 1 whole. Now, we can describe probabilities by writing them as a fraction, which you saw. But if we can write them as a fraction, they can also be written as a decimal or as a percent. So in looking at this number line, we would say that if it's at 0, that's going to be impossible. If you have a 1/4 chance of something happening, that's going to be unlikely. If it's a 1/2 chance of it happening, we would say that would be equally likely. A 3/4 chance of something happening is going to be likely. And if there's a 1 chance of it happening, meaning it is 1 whole, it is certain to happen. So notice that the greater the fraction, the closer we got to 1, the more likely an event was to happen. All right, so for page 10, which will be our final page for now, we're going to determine the likelihood and we're going to find the probability for rolling for one roll of a fair number cube. And notice that we're kind enough to let you know, hey, we're dealing with numbers 1 through 6. So if we're rolling a 2, that's a 1, there is only 1 2 on that number cube. And it's out of 6 because there are 6 total numbers on that number cube. 1 out of 6, if you think back to our number line, it's less than a half, but it's not 0. So we would say that it's unlikely that you are going to roll a 2. For rolling an odd number, there are 3 odd numbers out of 6, 1, 3, and 5. So that means that there is an equally likely chance that you would roll an odd number. rolling at least a 5. That means we're talking about the numbers 5 and the number 6, because it says at least a 5, so you can include 5 in this. So that means that we're dealing with 2 numbers out of 6, so it is unlikely that we would roll a number that's at least a 5. For rolling an integer, well, all 6 numbers are integers, because integers are going to be fractions, decimals, negatives, positives. So we end up with 6 out of 6 because they're all integers, so you are certain to roll an integer. Guaranteed. For rolling a number less than 3, there's only 2 of those. There's 1 and there's 2. So therefore, we would have a 2 out of 6 chance, meaning that it is unlikely we would roll a number less than 3. For odd numbers, if you want to add 1, 3, and 5, since I forgot earlier, go ahead. And for the last one, rolling a negative number, well, there are no negative numbers on that number cube, so that's 0 out of 6, so it is impossible. Now that we have gone through and determined the probability and determined the likelihood of some situations, now we're going to use that information that we've gained to help us find the missing outcome. We're going to find the missing probability. So for the first one, we have Coke, Sprite, and Dr. Pepper. The probability of getting Coke is 3/10. And the probability of getting Sprite is 1/5. We want to know, what's the probability of getting Dr. Pepper? So let's think about this. 3/10 and 1/5. We know that 1/5 can be changed into 2/10 to give us a common denominator. When we combine 3/10 and 2/10 together for what we already know, that's going to equal 5/10. That means 5 out of 10 chances of getting Coke or Sprite leaves us with 5 out of 10 chances for getting Dr. Pepper, because 3/10 plus 2/10 plus 5/10 is equal to 10 out of 10, meaning 1 whole, which all probabilities in a problem should add up to. Now, what if they don't give it to us in fraction form and they give it to us in percent form? Let's take a look at the next example. You sold the most for your school's fundraiser, so you get to enter the cash vault. There are $1, $5, $10, and $20 bills. The probability for picking a $1 bill is 48%. A $5 bill is 26%. A $20 bill is 10%. They want to know what the probability of picking a $10 bill would be. Well, we know if we were to add our 3 percentages that they've given to us together, that means that there is an 84% chance of getting one of those. Since we know that our percentages have to equal 100% because probability adds up to 1, we would say that there is a 16% chance of getting a $10 bill. Because if we were to add the 3 percentages plus the 16%, that would give us 100% or 1 whole.